In 1.4, we're going to learn how to solve equations and to solve problems by writing expressions. First, we're going to start with the simple ones, one-step equations. Hopefully this is a good review from Algebra 1. We always want to isolate our variable when solving an equation. So here we have x. We need to get rid of this plus 4. In order to get rid of something, you need to do the opposite operation. Since we're adding 4, we're going to subtract 4, and we do it to both sides in order to keep it all balanced. That means we're going to get x is equal to 8. In our next example, we have negative 1/3 x is 48. In order to isolate this x, we need to get rid of that negative 1/3. We get rid of fractions by multiplying by their reciprocal. So we're going to multiply this by negative 3 over 1, and we'll do that to both sides of our equation. That will cancel out our fraction, and x is going to now be equal to negative 144. Now we can take a look at solving multi-step equations. We're going to notice that here we have a variable on both sides of the equal sign. And we also have some parentheses. Two ways we could go about it. We could distribute that 3 into the parentheses, or we could divide both sides by 3. Since 3 will divide into negative 27 and 6, let's go ahead and do that. And make sure every single part gets divided by 3. So on the right-hand side, the 3 will cancel out, and that means we are left with negative 9 plus 2y equals y minus 3. Now we need to bring our variables to one side and our constants to the other. Let's subtract y to both sides. And it's going to cancel out here on the right. Then we're going to add 9 to both sides, so that way it cancels out on the left. 2 minus 1 just gives us 1y. Then negative 3 plus 9 will give us 6. And there is our answer. Notice how we used opposite operations anytime we are moving a variable or a constant. Notice that once we move a variable, it always gets lined up with its like term. And when we move a constant, it always gets lined up with the constant. Last thing, if you did want to check your answer, you could go back into the original equation, plug in a 6 anywhere there's a y, and see if both sides are equal to each other. Next, we're going to solve for x. And again, we have x's inside parentheses on both sides of the equation. That means we first need to get rid of the multiplication happening before we can move our values to the other side. To get rid of our fractions, we're still going to multiply by the reciprocal. 1/3 is a little bit of an easier fraction. So let's go ahead and multiply both sides by that reciprocal, which is going to be 3 over 1. So it cancels out here on the right-hand side. Then on the left, when we multiply by 3 over 1, our 3's cancel, and we're really just left with 2. So now we have 2 times x plus 3 is equal to x minus 6t. Now we can use our distributive property to give us 2x plus 6 is equal to x minus 6t. Then we just need to move everything to the appropriate side. Let's subtract x to both sides, and we're going to line up our x terms. So it cancels out. Then we're going to subtract 6 to both sides. Now 6 is a constant, whereas this negative 6t is a term, and they're not like terms. So we're going to put this negative 6 over by itself so we know that it stays by itself. And that 6 will cancel out on the left. So now we have x is equal to negative 6t minus 6. Your turn. Remember, we're trying to solve for y, which means you need to get rid of your parentheses first. Make sure that you multiply by that reciprocal of 9/4 and then subtract 3 to get your final answer. We just solved solutions that sometimes have an answer. We can tell that an equation sometimes has an answer if we ever get that our variable is equal to one specific number. But sometimes we're going to get an equation that is always true. If an equation is always true, then we're going to get one number is equal to that same number. And if it's never true, then we're going to have one number, but it's not going to be equal to the number that we get on the opposite side. In our first example, we need to start off by combining any like terms we have on each side of the equation. So here we have 11 and negative 7. And on our other side, we can combine our 6x and our negative 3x. So we're going to have 3x plus 4 is going to be equal to 3x plus 5. Now we can bring our x terms to the same side. We'll subtract 3x to both sides, making sure to line up our x's, and we're going to end up with those canceling out on both sides, which only leaves us with 4 equals 5. This is not a true statement, so this is an example of an equation that is never true. There's no number we could plug into both sides that would make the two sides equal each other. Go ahead and try the next one. Remember to combine your like terms on each side of the equation before moving on. After we combine our like terms, we have 5 plus 4x equals 4x plus 5. That's just the commutative property. We've changed the order, but both sides are equal to each other. So therefore, this is an equation that is always true. We could plug in any number we want for x, and both sides of the equation will always be equal. There are equations that we use to explain real-life scenarios. For example, the first equation is how we would convert from temperature in Fahrenheit to temperature in Celsius. If we want to solve the equation for temperature in Fahrenheit, we first need to make sure that we get rid of the multiplication happening on the outside of our parentheses. If we want to get rid of that fraction, we need to multiply by the reciprocal. And we're going to be multiplying by 9/5, which is going to cancel it out here on our right-hand side. But we also need to multiply the left by 9/5. So we're going to have 9/5c is now equal to f minus 32. Now we can add 32 to both sides, and we'll have 9 over 5c plus 32 is equal to f. So the temperature in Fahrenheit can be found by using this new equation that we've made. Next, we have an equation that we can use to find the area. If we want to solve for h, the h needs to be isolated. If we look at what operation's happening between the h and everything else on that right-hand side, we're multiplying by pi, and we're also multiplying by r squared. The opposite of multiplication is division. And even though we're multiplying by more than one thing, we can just divide by more than one thing. So we're going to divide by pi r squared, and we do that to both sides. So it cancels out here on the right, and we're left with it on the left. So h is now equal to the area divided by pi r squared. And here's our new equation. Let's take a look at a word problem. We have a carpet that has a perimeter of 200 meters, and the length is 3 times longer than the width. What are the dimensions of the carpet? We're going to start off by drawing a picture. Sounds like we probably have a rectangular carpet, and we are trying to figure out what is the length of this carpet and what is the width. Well, we need to have an equation that relates perimeter, length, and width all together. Remember, the perimeter is equal to 2 times the length plus 2 times the width. But now we need to figure out, what are our variables? Yes, we have length and width, but we can't solve for 2 variables at once. So we're going to say that w is going to equal our width. We need to try to write the length in terms of the width, meaning how many widths are the same thing as one length. If we go back to our problem, it gives us that answer. It tells us that the length is 3 times longer than the width. So if we have one length, it's the same thing as doing 3 times our width, or 3w. We also know that our perimeter is 200 meters because the problem tells us right there in the beginning. Now we can put this together to write an equation. We're going to say that our perimeter is equal to 2 times the length, but remember, our length is going to be the same thing as 3w plus 2 times our width. Well, that means our perimeter is equal to 6w plus 2w, so the perimeter is equal to 8w. Now we can solve this. We're going to plug in that 200 for p, and so we have 200 equals 8w. Divide both sides by 8, and our width is going to be equal to 25 meters. But we can't stop here. The problem asked us for the dimensions of our carpet. We need to figure out what exactly is the length and what exactly is the width. We know that the width is going to be equal to 25 meters, but the length is equal to 3 times the width, or 3 times 25, which gives us 75 meters. And this now is our final answer.